So this is Asif. I'm the host for the evening, and welcome everyone. Thanks for joining for the webinar here. So today's topic is overview of UniPro UFS protocol analysis, and the overall session is going to be roughly for around 1 hour, and the first 45 to 50 minutes is going to be the introduction and the product demos, as per the agenda. And the last 10 minutes, what we're going to do is we're going to have the question and answer session. Okay. So since it's a webinar, if you have any specific questions, there is a Q&A tab in the Zoom. I mean, you can see there. So you can go ahead and type in your questions, and we'll be happy to answer your questions. Most of the questions we'll try to answer towards the end of the webinar, but if there's something very interesting, we can pick up in between. Okay. So the session is getting recorded. So in case you miss any of the some part of the session because of connection issues or some other reason, the session is recorded. The recorded session link will be sent to you guys directly after the webinar. That's tomorrow. Okay, so let me introduce the speaker for the evening. So the speaker is Godfrey Coelho. Godfrey Coelho has overall 25 years of experience in test and measurement domain. He's the founder and CEO of Prodigy Technovations. And he started his career with HP, Agilent, and then later on worked in Tektronix. And for the last decade, he's been running Prodigy Technovations. So Godfrey, it's over to you right now. So you can take over the session and you can start discussing with the rest of the team. So I'll join in somewhere around 45 to 50 minutes from now, or if there's any help required, I'll help the folks out. Thank you.
Thank you, Asif. Good morning to North American team people, and good evening in the Europe. So my name is Godfrey, as Asif introduced, and I'm going to present for the next 1 hour. Today's agenda is we just like to give a very brief introduction to Prodigy Technovation. With those who do not know Prodigy Technovation, we can like to give you some overview about the organization. And then we'll talk about MIPI, UniPro, and the UFS protocol. And then we'll introduce to you PGY UFS 3.1 protocol analyzer from Prodigy Technovation, and then followed by a demo. And then quickly we'll give you some overview about UFS 4.0. That's agenda for today. Now, about Prodigy Technovations, we have founded this company in year 2009, developing software applications for Tektronix oscilloscope. We are based in Bangalore in India. That's our current office, but we do have distributors in different parts of the world, from Japan to US, China, Korea, Southeast Asia, Europe. So we are currently around 39-member team, and sometime in 2014 we started developing hardware-based protocol analyzers based on the customers' feedback. And our first protocol analyzer was EMMC, SD, and SDIO protocol analysis, and which is now actually the UFS is the higher performance flash technology. And now we are providing a solution for UFS, and we have different range of other protocol analyzers like I3C, RFFE, SPMI, I2C, SPI, so a lot of them, and we have some of those coming up too. And we have two business divisions. One is the protocol development division, where we do different protocol analyzers. We also distribute some of the American companies' product in India, such as Aldec, Vectorsoft, and PTC. So our customers are like top semiconductor companies are Prodigy Technovations customer, Intel, Qualcomm, Micron, SanDisk, or WDC now, Kioxia, Qualcomm. So these are our customers. So we have a wide range of customers, starting from semiconductor to memory and the systems organizations. So let's coming to the MIPI standard. MIPI is a physical standard, physical layer standard, which mainly deals with the electrical specifications of the UFS protocol. and also the physical layer of the protocol, like symbols information and packet forming. So M5 supports 4 high-speed data rates, starting from HS gear 1 to gear 4. And within these data rates, there is a rate A and rate B. So the rate A starts with 1.25 gigabits, and the rate B is around 11.66 gigabits. So that's a maximum data rate. Okay. So the protocol, the data can either be transmitted using HS gear 1, gear 2, gear 3, gear 4. And there is also a low speed data rates which M5 supports, starting from PWM gear 0, that's almost 0.01 megabits to, and going up to PWM gear 7 around 576 megabits per second. But in case of a UFS, it uses only PWM gear 1. So this data rate is starting from 3 megabits per second to 9 megabits per second. So PWM data rate is in this, and that's what UFS is using. So if you really look at the protocol layer, the most of the initialization of the host and device takes place at PWM. When the data has to be transferred, it switches over to different high-speed data rates starting from gear 1 to gear 4. So depending on the requirement, the user can choose what data rates you want to use it to transfer the data, and accordingly one can send the data at high-speed data rates. Okay. So that's physical layer data speeds. Now in M5, there are 4 lanes are there. There are 4 lanes which going from device A to B, TX to RX of the device. And similarly, the 4 lanes will go from device B to A. Okay. So this is how the M5 standard supports 4 lanes. But in case of a UFS, there are only 2 lanes are used. 2 lanes will go from device A to device B and device B to device A. So it's a UFS is a supports 2 lanes of the M5 standard. And there are also some devices which are maybe removable devices. They may use only 1 lane from device A to device B, and or device B to device A. It's a 1 lane also. So there is a flexibility. You can configure the lanes dynamically on the data while transferring the data using a power mode protocol packets. So you can either choose lane 1 or lane 2, or a combination of host to device 1 lane and device to host 2 lanes. So it has built in a lot of capabilities so that it gives designers a lot of flexibility and try to save a lot of power and use the number of lanes based on the need of the application. So that's about the number of lanes. Now, how does the data is transmitted between the host and device to host? So the data is transmitted using the burst communication. Okay. So there is a burst when there is a data transfer takes place. When there is no data transfer takes place, the bus can be in a stall or a no electrical activities on the bus. Okay. So basically, again, it provides a lot of power saving because of this burst communication. But it also offers a lot of challenges for a designers, how to sync up the host and device, and how to identify the different data rates because it's dynamically changing. So it has a lot of complexity built in at the hardware level to synchronize with the incoming data. Now, the good part about M5 is that all those complexities are well addressed in the data transmission. Okay. Now, the data transmission, as I mentioned, can take place in PWM state, that is a pulse width modulated state, or in a HS high-speed burst state. Okay. When the PWM state takes place, there will be a first thing is that there is a sleep, which is a differential N. It's a low power state. Then it goes to the prepare state where the diff-P gets activated, and then it might send sync, and then the marker and filler and data, and then the end of burst. Okay, so this is how the PWM activity can take place. Now, in case of a high-speed burst, so you have a stall state, which is basically electrically idle state. No signal transition takes place in the stall state. And then there is a prepare state, which basically driving the diff P line high. And then there can be a sync, and then the markers and the filler data. These markers are used as a alignment patterns to identify the start of the burst and the end of the burst and the filler, those kind of purpose. Now, why the sync is transmitted is an important part, because the each burst can be at a different speed. So the receiver, which is a PLL, which is be receiving locking to the incoming data, needs to recover the clock and data, and the sync is used for that purpose. Okay. Now the number of sync symbols can vary. The maximum is around 4,000 symbols. But what we are seeing is that commonly most of the UFS devices use 256 symbols. In the sync area, there is a continuous changes in the ones and zero, so that the clock and data can be recovered and the PLL can lock to the incoming data. Okay, so this is how the sync is being used in UFS. Now, why there is a adapt packet? Okay, now as we know that UFS initially worked at UFS 2.1, that is at a data rate of HS gear 2B, which is around 5.8 gigabits. Then it came UFS 3.0, where the data will move to HS gear 4B, where it is the data rate is around 11.6. Now, when the data rate is very high, there is a equalizers are very extensively used to boost the signal level to compensate for the loss in the transmission channel. Okay. Now, the adapt packet is nothing but a PRBS pattern is being transmitted whenever bus is switching from HS gear 3B or lower speed to the HS gear 4B. Using the adapt pattern, it will adjust its equalizers, and so that the data is completely recovered, because it's a known pattern. It is a known PRBS pattern is transmitted by both the host and device. Using this PRBS pattern, both the host and device will tune their equalizers to recover the data properly. And once the data is properly tuned, then there is the data transmission takes place between the host and device in HS gear 4 speeds. This is applicable for both rate A and rate B. So this is how the burst at high speed burst and the PWM burst are formed in a MIPI layer. Now, if you really look at the burst, you can see here, like in a waveform format, you have a prepare state where diff P is going high, and then there is a sync length. As I mentioned, this can be varying of different length. All this information is shared between the host and device during the initialization of the devices using a power mode PACP packets. Then there is an alignment pattern for SOB, DL data, and the fillers, and this can continue. And at the end of the burst, there can be another PHCP packet, and then the end of burst. And when there is no data to be transmitted, it can be in a stall or a hibernate state. And this is hibernate state is well captured in the PHCP packet in the previous burst. Accordingly, this state will be either in a stall or a hibernate in HS mode, and then it can again start with the prepare. Now, the timing of the prepare and sync length, all these are captured in the M5 specification document from the MIPI Alliance. If someone is very interested to know about these specifications, so it is accessible from MIPI Alliance once organization becomes a member of that group. So this is about how the HS burst data would look like when we see it in a time domain form. Now, what are the different control symbols are used? Like just to give an idea. So this M5 is a 8B, 10B encoded data. So all the 8B are encoded into a 10-bit patterns using RD-1 or running disparity +1. And some of them are reserved, some of them are used as a markers and fillers, and some of them also used as a skip characters. So these are the different alignment patterns used at the file layer in order to identify the start of the burst, end of the burst, or the fillers, or the skip characters. So these are some of the very used control symbols in M5 data transmission. So these are the packets which are actually identified in the protocol analyzer to know the start of the packets. So there are different power saving states because M5 was designed for low power applications. So as I said, it is a burst communication. When there is no data transfer takes place, there is no electrical activity takes place on the physical layer. And in the HS mode, when the bus is in the high speed mode, the electrical idle or no activity is known as a stall state. In the PWM state, that is a low speed mode, it is also known as a sleep state. And sometimes the bus can be on the hibernate state. This is again defined in the previous packets, PSCP packet, and where the bus can get into the hibernate state and recover quickly to transfer the data. And there are also disabled and unpowered states. So these are the different power saving states which are available in the M5 layer. Now looking at the different protocol layers in the UFS, so if you look at thread, there is a physical medium which will actually can be an optical or it can be a copper. In this case, most of the UFS protocol is embedded in nature. There is a host SOC and there is a device which is sitting on the board. So they are interconnected using a PCB traces, maybe they are impedance control traces. And then you have a physical layer where there is a PHY adapter layer, which will control the PHY layer of the bus activity, a number of lanes or a hibernate state or at what speed the bus has to operate. All these are part of the PHY layer operations. Then you have a data link layer, network layer, and the transport layer of the OSI. All these three things are part of the UniPro specification. And again, UniPro specification is from MIPI Alliance, and currently publicly available spec is 1.8 version. And again, one can access this UniPro specification by being a member of MIPI Alliance group. And then on the top of it, you have a application specific protocol, and where currently this application UFS is utilizing this application specific protocol to do the data transfer between the host and device on the flash memory. So this is how we can map the UFS layer protocol to the OSI layer of the protocol stack. Okay, so this is how the protocol layers is defined in UFS. Now coming to the file layer, that is a 1.5 spec we call it sometimes, right? 1.5 layer, L1.5. So there are different PSCP packets. There are packets called power mode change packets. These are mainly used to define the number of lanes to be used for data transfer, whether it is the bus is going to the hibernate or whether it is going to be on what speed the next burst is in, whether it is in HS gear 1 or gear 2, gear 4. So all those data will be present in the power mode change packet. And also the rate A and rate B information is present on this. Okay, so this is very commonly and widely exchanged packet in UFS. There is also something called fast auto and fast mode. So this is also a part of the PSCP power mode change packet. Then we have a PSCP capability packet. This packet will mainly transmit exchange during the initialization of the host and device. Okay, so this will have the information like timing required for prepare state, how many sync symbols are required by the host to lock the incoming data, how many sync symbols are required by the device. Okay, and there are other electrical information. All those will be part of the capability packet, and these are exchanged during the initialization of the device. Okay, then we have different test mode packets here. They are maybe mainly used for I think testing the file layer. And then we have a PSCP get request and PSCP set request. These are used to set the attributes of the host and device, and the request is mainly goes from the host side of the UFS, and the confirmation is comes normally from the device side. So for every PSCP request packet, there will be a confirmation packet, so one can analyze in that format. So these are the different PSCP packages which are present in the UFS, in the file layer. The next layer is a data link layer, where the data is transferred between the host and device and vice versa. So in the data link layer, we have a DL data packet, which DL data packet can be used for command, or it can also have to send the payload from the host to device or vice versa. There are first 4 symbols are used in the data link layer at the UniPro layer as a control characters for the UniPro layer purpose, and the last 4 symbols are used again for the controls information such as um, sequence numbers and traffic class and the CRC values are present in the DL data frame. The control frames mainly for flow control purpose. If the data is successfully received and processed, it will give acknowledgement. It is called the AFC packet. And if there are some errors, and the host or device can send out a NAC packets, which is basically negative acknowledgement. It mainly says that host or device to retransmit the DL data, or sometimes it can reinitialize the entire communication between the host and device. So this is a very high level. How does the UniPro layer data packets would look like? So I will be giving you a demo, and I will talk about these packet formats in more detail. And it's easy to for you to know how these packets would look like and how they are can be analyzed. So that's DL data and control frames. So then on the top of the UniPro layer, we have a application layer. Now in this case, it's a protocol, UFS protocol overview. And these packets are called as UPIUs, UFS Protocol Information Unit. They are mainly exchanged between the target and the initiator and the targets. Basically in UFS standard, they talk about initiators and the target. Initiator is nothing but a host, and target is a device here. So the UFS packets will have around 32 symbols, which will have a header segment information, which are used to define, for example, read 10 commands or write 10 commands with a logical block address and with different flags for giving a lot of information between the host and device and how much data to be transferred. All those information will be part of the UPIU packets. Okay. Now there are different types of UPIUs in UFS layer. The NOP out and NOP in. So the NOP out is initiated to the target. Okay, it is transmitted from the initiator to the target. It is something like a ping in internet domain. So NOP out and NOP in. There is a, for every NOP out we can expect a NOP in response. And there are different commands are issued from from the initiator to the target device. These commands will have a command descriptor, and all the command parameters are included in that. And there are multiple commands. We'll see them in details later on during the demo. There is a read 10, write 10, read 6, and there are so many different commands are available, unmap and so forth. Okay. Now, every command, after completion of the command's activity operation, there will be a response which will be issued by the target to the initiator to indicate that the command has been successfully completed, and the response will give the information to the initiator that this operation is complete. And then you have a data out and data in. Data out is like data is going from the initiator, that is from the host to the device, and data in is from the target to the initiator. Okay, this is for the write operation, and this is the data in is for the for the read operation. Then we have a task management request and response ready to transfer. So whenever there is a write activity does and the device will say it is ready to receive the data, so ready to transfer, and the host will send the data to the device. Then we have a query request and a query response. So again, to manage the data, the communication between the host and device. These are the main UPIUs, that is UFS protocol units. So we can decode them and we can analyze it. So now that's about the overview about MFI, UniPro, and UFS protocol in a very brief. And there is one can go through these specifications in detail. There are multiple documents are there, but I'm just giving you an idea at a very high level. What is M5? How does the data looks like? How does the data looks like on UniPro? And what are the different UFS commands? So let me now introduce to Prodigy UFS Protocol Analyzer. So this product supports M5 3.1 and M5 4.0. So M5 2.2 or 3.1, it is for UFS 2.1 specification, and M5 4.0 is for UFS 3.0. So basically in M5 4.0, the data rate can be up to HS Gear 4B. That's the maximum data rate, that is 11.66 gigabits per second. Then the UniPro spec is 1.61 and 1.8. Then UFS supports 2.1, 3.0, and 3.1. UFS 3.1 has a HPB support, so Prodigy Protocol Analyzer supports the decoding of HPB packets. Then we have a supports PWM Gear 1 to Gear 7, but in case of a UFS, we only use PWM Gear 1. So Prodigy Protocol Analyzer will be able to capture these packets, Gear 1 speed packets, and decode them. Then it also captures HS Gear 1, 2, 3, 4. That is starting from 1.25 gigabits all the way up to 11.66 gigabits at rate B. So that's the support available on UFS 3.1 protocol analyzer. One of the important feature in Prodigy protocol analyzer is a continuous streaming of the protocol data to the host computer. So this will enable the customers to capture the longer duration data when the throughput is within the limits of the communication between the host and the analyzer. And so it gives you a lot of flexibility to run slow throughput data rate test cases over a long period of time. And Prodigy offers you one of the best solder down active probe solution to access the test points, because most of the time the UFS test points are embedded on a board, so it is very difficult to probe them. So the solder down probe somewhat makes it convenient, where you can solder to the test point and look at the protocol activity. Then we have a decoding takes place at M5, UniPro, and UFS layer. You can also trigger on M5 content and UniPro content, UFS layer packet content. And we can do a field upgradation of the hardware firmware because there is a new feature gets added and the new firmware gets released. We will provide you the firmware. You can upload that right in your office. We can also provide a continuously the software updates based on the field feedback, and then there is a report can be generated, and it's a very lightweight. You can carry it to the field. It does not occupy a lot of bench space. It needs a very less bench space on your in a very congested test bench. I have seen many times there is a there is no place to keep the test equipment. So many cables, wires, test equipments. So this product is really compact and easy to use. So the probing is one of the most complex, and Prodigy offers one of the industry best probing solution. So we offer these probes which are active probes in nature, where you can connect to the plus and minus of the test points, and then the active circuit in this probe tip will drive the signal to the protocol analyzer through the mini SMP coax cables. These are high bandwidth cables with the 40 gigahertz in bandwidth. These probe tips are not very expensive. They are quite a low cost solution and provide you a high performance. You can also use them multiple times. You can solder them to a DVT, and you can desolder. You can put it onto the another DVT. So in this picture, you can see this. We have soldered this probe to the one of the evaluation board directly to the test points, and able to do all the analysis. Now, Prodigy also offers you some another long wire probe leads actually. So where we have a same probe tip with the extended, because there is very limited space available for one to place these probes at the test points. So in order to access those test points, we have a long lead wires here. These are differential wires, high bandwidth wires with the isolation circuit at the front, and we've offered them with the equalizer and without equalizer. Based on the requirement, one can use them. And so this is also another flexible solution available from Prodigy Technovation for probing UFS test points. We do have an advanced probing solution. This we normally offer this solution based on the customer DVT. So if you have a very specific DVT which is difficult to probe, I request you to contact Prodigy Technovation. We will share our contact details in the last slide in this presentation. You can note down, plus you can have contact details from Prodigy website. You can as well as contact our distributors in different parts of the world, and we can work with you in developing a very robust probing solution. So the overall test setup would look like this, because you've seen the probes. How does the setup, you would be wondering. So we have, this is a SM8150 test platform with the Snapdragon 865 and a UFS 3.0 device on it, on a socket, okay. So we have connected soldered the probe tip to the test point, and these probe tips are connected to UFS Protocol Analyzer using a mini SMP coax cable. These cables are almost 0.5 meters in length. In case if you need a longer length, we will offer you that option too. So you can order longer length cable from Prodigy. Then these probe tips, which are active probe tips, they do need a power to them. So you can power them using a power module, which is from the protocol analyzer. There is a small power module which will power the probe tip, and the protocol analyzer is connected to the host computer using a USB 3.0 standard available interface in the market. This is how the test setup would look like. Now, once we make the test setup, we need to configure the analyzer to acquire the data. Some of the required inputs are like, what is the device clock, whether it is a 19.2 megahertz or a 26 megahertz, okay, or a rate A, rate B, or you can also choose on the latest version rate A plus B. So some of the DVTs start boot from rate B and switch to rate A. So all those flexibilities are available. Then you can do a channel assignment, like you can choose all the 2 lanes, or if you are using only 1 lane, or if you want to capture only the host traffic, you can do it, or you can capture only the device traffic, you can do it. In case if you are soldering the probe tip to the test point, right? If they're inverted, it means like if you are connected the plus of the test point to the minus of the probe tip, then you can invert them in the software. You can also see the different M5 states. So this is basically a, like you can make the settings. And in the advanced setting, you can select the analyzer can recognize the burst speed based on the sync speed or the PACP or the power mode change packet, which is present in the previous burst. And then it can look at the speed at a different sync wait time. You can set the host and device equalizers, okay? The CTLA and DFE, you can do that. You can change the frequency boost and wideband gain. Also DFE gains, you can set both separately for a host as well as for the device. Then acquisition, you can do a live decoding, or you can capture the data, stop the acquisition, then transfer the data, and then you can decode it. We can also have a hardware filters where we can drop the AFC packets and DL data payload, the information which is not really sometimes required for analysis. We have a continuous, like a streaming capability, as I mentioned, and we can do a continuous capture. We also support circular buffer, and on the fly, it can compute the CRC errors or AFC errors. As it decodes the data while in the live mode, it will report all the errors, and while it is decoding, you can go and search for them also. So all these are, you can make a setup just prior to the capture and start capturing the data. Now, this is the diagram which gives a very high view of how the hardware works. The probe tips which collect the signals and they goes to a FPGA. We are using Kintex 7 FPGA on this platform. So this will identify the packets and form the packet, and then it will store on the DDR3 memory. From the DDR3 memory, it will go to a host computer. There's one more FPGA which will do that transaction. So it is designed such a way that these overall hardware or the logic is not overloaded. So there is a separate state machines are available to capture the data and then read it from the memory and send it over to the host computer so that we can get the best performance. So the smart drop is one of the important feature because always in a protocol analysis, we would like to capture the data for a very long period of time. So naturally, we like to, when we know what is sync data is, we know what is a filler is that sometimes we are not interested in payload. We just look interested in the overhead information. May not be interested looking at all the AFC packet for a DL data. We may like to see only one. So the smart drop capabilities in the Prodigy Protocol Analyzer can enables you to capture the acquisition duration maybe 3 to 5 times. Okay, so you can do that by selecting the smart drop feature, and also, like as I mentioned, you can select AFC packet drops. Now, how does the AFC packet, just to give you an idea, so every DL data packet may receive multiple AFC packets. By selecting the hardware filter, you can just, we'll have only one AFC packet transferred to the software, and rest all will be dropped in the hardware level so that it will save the bandwidth as well as the memory, and also make the software much more responsive. Otherwise, so we will be decoding all of this and displaying it for you. So based on the need, one can choose these hardware filters, or one can have look at them everything, because if you're really interested in credit value, you may like to have all these AFC packets captured and displayed. So please send your questions if you have it, because we are now having only 20 minutes, I think. Let me try to go a little fast, maybe skip few slides in case required. We have a circular buffer. Okay, the circular buffer is a very powerful feature what we have in our protocol analyzer, which enables you to capture data for a long period of time. And but you may not be interested in looking at all the data for the last 1 hour. You may like to just look at the data for just 1 GB or 2 GB of data. You can just look at the last 2 GB when you click on the stop, and then you can decode it. So it is a real-time hardware circular buffer. So it will just hold the last buffer size, and the buffer size can be selectable in the steps of 500 MB, 500 MB to 7.5 GB. So you have these capabilities in the protocol analyzer. So here, one of the nice presentation of our software is that you can see the UFS layer packets and the UniPro layer packets and the symbol information simultaneously on the screens. All these windows, the views are dockable windows. You can move and place wherever you want. You can make your own look and feel. You can change the background color of the command, whatever, how you would like to see, or you can also like to change the font color. It's all your choice. Okay, so once you make these settings, you can save and recall them, or it will be there for your laptop and you can continue to use it. So we have other views like PHCP view, analytics view, report, trigger views. So these are all enables you to look at, because you have billions of packets of data, and it is extremely difficult to sometimes look at where is the PHCP packet. So we separate them out, we show them in a separate window, and when you click on that, automatically it links to the UniPro layer, and exactly you can see that packet along with the rest of the packet information. So it helps you to debug further and saves a lot of your debug time. So in another view, we can also have the frame view. So if you select a UFS packet, the details of the packets are shown here all the time. Similarly, you have it for UniPro layer. So all the UniPro DL data packet details are shown in the frame view packet view. Then in the analytics, you have gives you a very high level bird's view for the UniPro and UFS packet. You can see how many packets have been decoded, DL data from the host and device side, how many AFC packet, SOB, UOB status, PACP power mode, power request, confirm packet, all this information you can get to see at a very high level. And similarly, you can see them for the UFS layer also. Okay, so it's a kind of a very high level information when we're trying to debug that. And you can also see real-time CRC error, hibernate information. So in the entire data, how many CRC errors are there? Is there a mismatch between the request and confirm packet? Is there a mismatch between the frame sequence number? So all these things, analysis are done on the fly and displayed to the users. And you can actually go and search for it by selecting if there is a mismatch or any one of those things. So this is a graphical representation, the histogram and pie chart of the histogram analytical information. This is for the UFS. And this is one again for the PHCP power mode packet, where we will show you all the PHCP packets in a separate window with all the attributes. You can select what you would like to see, the number of lanes, the speed, it's switching over to gear 4A to lane, and different flags. All that information will be present in this view. So then in the trigger packet, so we can select control packets. So you can select a control packet, you can select on a PACP, you can select on a specific C port, if there is any lane merger error. So you have a flexibility to set trigger conditions on the MIPI layer. Okay, there are three modes are available. Auto trigger basically triggers on any package which goes on between the host and device. Simple trigger, which is basically you can just tell what type of packet you want to trigger, whether it's a PACP packet or a DL data packet, or you can select the frame trigger, where you can select the packet. You can also set the different attributes of it, like when it is going to the hibernate you want to trigger, so you can set all these parameters, and you can trigger on any one of those PACP packets. Similarly, we have it for UFS layer packets, okay, and you can really specify all these parameters. You can select a command, and in the drop down menu you can choose the command type, and then you can enter these attributes and set this as a trigger condition. And here you can look at your different views again. These are all correlated. Like if you select a UFS packet, it will indicate which is a corresponding UniPro layer packet and what are the symbols in the file layer. All this information comprehensively shown in a simple GUI user interface for you to debug. Okay, and then you have a advanced search, filter, and analysis. You can search, filter out, filter in. So these are very commonly used features. This makes it debugging very convenient. It's very responsive. Like when you have a few gigabytes of data, the software should be able to search for your interested packet quickly and easily. All those things are taken care in the UFS software. And this is a filter in, just to give you an idea. So it will just to keep these packets and drop rest of the information from the GUI. Okay, but it is there in the database, but in the GUI it will be removed. There is a filter out. So filter out would remove the selected packets, and the rest of the information is displayed. So you can apply it for a UFS layer or a UniPro layer also. Okay. And when you really want to debug a lot of data, looking at these different views like UniPro, MFI, or UFS is a kind of a time consuming. So you can drag and drop to the second monitor and you can view them separately, and they're still time correlated, and you can do Prodigy, make use of the Windows capability so that it simplifies your debug efforts so that you can easily look at the data in different larger screens. So let me now quickly show the demo. In between, we have still 15 minutes. Let me try to do a
So
demo.
Godfrey, there's a question as well. So you,
Okay. Okay.
uh,
Please go ahead, Asif.
yeah,
Yeah,
yeah.
let me
So
bring.
when
Yeah.
you filter a AFS packet and just show a single line for a contiguous AFS packet, do you show the count of how many packets were collapsed?
Yeah. When you look at it, we'll give you a count, and you can jump one by one. Actually. Okay. So this is a UFS software what we have. Okay. So Asif, can I go to the demo now?
Yeah, yeah. We can see the demo. Yeah, we can see.
Okay, yeah. So this is I've loaded the waveform trace file onto software, and here we have a UFS view, UniPro view, and the host view and the device view. Now we can resize all these views of the windows. Okay. And in case I would like to see more information about the UFS, I can just do a right click and go here and select I would like to know the speed of the burst, task tag, maybe EHS length, data segment length, and maybe loan information, expected transfer length, and so forth. Now I can always resize these windows a little bit based on my requirement. Okay, so that I can see most of the information. Similarly, I can choose here gears, and I can maybe choose frequency, credit value, CRC, some of these PACP information. I may like to see them separately. So I can go. Now here I have a, like if I like to see a PACP information, which is having separate view here, and let me see, I would like to see everything which is possible for the PACP view. So we can see here the devotee is in HS gear 1B initially. I think then I did actually power reinitialization. So it goes to the actually uh, initialization trigger UPRO packet. It start sending link initialization packets, and then it exchanges capability packets, which I mentioned you. So which you can do a right click and you can say show detail. Now we can go and see what is the sync length required for HS Gear 4. This says around 4B, which is around 2000 sync symbols. As per spec, it can go up to 4000 sync symbol. But for this device, it is around 2000 sync symbols requirement. Okay. So we can see them in detail. Like now, if I go to the capability packet, first extension 1, so I can see more information about different parameters. Okay. And they're also further decoded and displayed on the screen. Okay. So these are all as per the MIPI Alliance specification document, and you can look at them in detail and find the information. Similarly, the device or host is exchanging the packets, and then there may be like, they may switch the speed to higher speed, gear 1, and you can see here a power mode change packet indicating that there is a data transfer takes place. Okay, so you can see here, this is the packet here, and they are all correlated. Like moment I select a confirm packet, we can see it is now changing to HS gear 3B. Okay, so as we move along, then we will see this data is in HS gear 4A. Okay, so this is in HS gear 4A, and you can also see the adapt packets which are decoded and displayed. So you can see now, suppose you would like to see a DL data packets content inside, you can do a right click and say show details. So you can see the UniPro layer overheads, Okay, then you can also go down, scroll down, and you can look at the trailer information, frame sequence number, and CRC. So this is how this entire software will operate. Now, if I go back to the UFS layer, I can go back, select UFS. If I select, let's say, start stop unit, it will also show me the corresponding DL data packet. So you can see your same timestamp. And if I would like to look at the decoding of this packet, I can see some information, but I can also see more information by clicking on show detail, and then I get a complete information of this command. Now this is how one can decode it. Then we have a write 10 ready to transfer data out. Now if I would like to see what is the data which is transferred for this write data out packet, I can just click on this thing and I can see all the overhead payload information here. So it can be go up to 4 kilobytes, I think. So we get to see all that information. Now for this corresponding data out, there will be multiple DL data packets in the UniPro layer. They all will be shown in a blue color actually. Let me choose this one, and you can see here they all in a blue color. So you can also see number of SOBs. If you click here, you can see for one lane, you get 2 symbols. For 2-lane data, you get 4 symbols. This is one way you can also easily, quickly identify it. Okay. So this is about the overall information. Then we have a UniPro layer analytical information. Then we have a UFS layer analytical information. Then we can generate a report using a CSV file format. Okay, and so we can like we can choose in the report what all information we want, and we can also set different trigger conditions as I mentioned. If I select command, then I can choose any types of command I want to trigger on write 10. Then I can make this full screen. You may be finding it okay, it's difficult. So I can make this full screen and I can change this width and I can enter. I can drag and drop to the second monitor. So we can do all those things. There's a lot of information is present in the software. That's why we created multiple views, and there is a flexibility to float them and drop them into the another monitor, and you can view them. We also have so many markers, unlimited number of markers we can set, and we can look at easily the timing also. We can also name these markers like A, B, C, something like that. And when we debug, when we actually debug that and we want to go back to the particular marker, it will be sometimes difficult to recall which marker we should go. But naming them, it makes it very convenient to go to that particular location because we can associate that marker with maybe a specific event in the protocol activity. So we can look at the timing information on the UI, and there are multiple markers are placed. We can just select between M2 and ABC, what is the delta. So all this information will be available. So this is a very brief overview of the product. And maybe when we can now take questions because we have a few more minutes now.
Yeah. Okay.
Yeah.
So Godfrey, I have a couple of questions here. So basically, does the UFS Protocol Analyzer support hardware filter?
Yes, it does support hardware filter.
Okay. And the next question is, in case you're using circular buffer, what are the different sizes which you can do with the circular buffer?
Yeah, circular buffer, we can go in the steps of 500 MB to 7.5 GB. So based on your requirement, you can choose the size of the circular buffer. So it will retain the last, when you clicked on the stop acquisition, it will retain the last, whatever data is present in the circular buffer, it will read that and it will decode and display it for you.
And can the probes which have been mentioned reused?
Yeah, the probes are reusable. You can always remove them from the one devotee and put it onto the another devotee.
Okay, so if people have more questions, you can go to the Q&A tab and quickly type in your questions. We'll be happy to take a couple of more questions. or yeah. So you can see the, or you can type in the chat window as well. So we can take. Okay. Thanks, Mike. Yeah, but yeah. Godfrey, yeah. So there's a question here.
Yeah.
So when saving into the CSV, can we specify the areas to save?
Yeah, you can actually save between the markers also. You can place the markers either in a UFS layer or UniPro layer, and the only that the data between those two markers will be saved. This is a very good question, because when we have a 8 GB of lot of data, and we want to share it with our teams in remote places, it sometimes takes a lot of time. So we provided a flexibility to save between markers so that you can send only the data which is necessary.
Okay. And does it support M5 Gear 5?
M5 Gear 5, that's a good question. That's a
So
question which is,
Godfrey, I will not able to hear you. Can we
yeah,
able to?
that's a good question. I said it's a question which is related to UFS 4.0. Okay, so we are, let me, okay, am I sharing the right slides? Okay, sorry. Yeah, I think Prodigy, we are working on next generation protocol analyzer, as I mentioned, because the specs are not announced publicly. So we request you to contact us. And since it is many of the products are not available in the market for UFS 4.0, and no one would like to discuss this in a public domain. So Prodigy is open to sign NDA with our customers, potential customers, and we can provide you a UFS 4.0 for protocol analysis solution, which will have a HS Gear 5B a protocol decoding.
Okay, thanks, Godfrey. Thanks for the wonderful presentation. And for people who have any specific questions, you can write an email to us at contact@prodigytechno.com. And those who are interested in either a demo, or if you are interested in one-on-one consultation or an eval unit, you can have a request sent to us, and we'll be more than happy to help you guys on a one-on-one basis.
Yeah, I saw one question. What is a sync symbol requirement for Prodigy Protocol Analyzer?
So we just want to ask one more.
Yeah, that's a good question actually. We don't need much. I think at a very low sync length we can lock. That's what I can say. Even DVTs with 256 or even 126 sync symbols, we are able to lock and collect the data.
Okay.
So
Okay.
thank.
Yeah, any more questions? I think if people have last one more question. Okay. No. No, I don't see any more questions coming here. Yeah, so as I told before, so there is an email ID, contact@prodigytechno.com. Please write to us for one-on-one discussion or one-on-one demos. We'll be more than happy to help. And thank you all for your time. Yeah, for having your patience for 1 hour listening through the presentation. And so I'm calling the end of the session, and good evening and say good morning to, based on your region where you are. And thank you everyone for your participation, and thanks Godfrey for your
Yep.
patience and running through the complete presentation for 1 hour.
Thank you.
Okay.
Thanks a lot. Yeah. Bye.